Welcome to
Nay.
Do it.
Channel Everyone. This is episode 2020-60320. Okay, so today we are diving into something called cuGenOpt, a GPU-accelerated framework for combinatorial optimization. JJ, that sounds like a mouthful. Can you break that down for us? What is combinatorial optimization and why should we care?
Of course, Isabel, think of it like this. You are planning a very complex road trip. You have many cities to visit, but you want the shortest possible route to save time and fuel. That is the classic traveling salesperson problem. Or, imagine you are a logistics manager trying to pack delivery trucks in the most efficient way. These are all combinatorial optimization problems. The challenge is, the number of possible solutions explodes as the problem gets bigger. It is like trying to find the best arrangement of a giant puzzle, where trying every single piece is impossible.
Exactly, and for years we have had a trade-off. You could use a general-purpose solver, which is flexible but often too slow for real-world, large-scale problems. Or, you could write a highly specialized, hand-tuned algorithm for one specific problem, which is fast but takes expert knowledge and months to develop. What cuGenOpt proposes is a new path, a general-purpose framework that runs on GPUs to get that specialized level speed.
So it is trying to be the best of both worlds, general but also fast. How does throwing a GPU at the problem make that possible?
The key is parallelism. A modern GPU has thousands of cores. Traditional solvers often run on a single CPU core, exploring one solution path at a time. cuGenOpt's architecture is, one block evolves one solution. This means it can explore thousands, or even millions, of potential solutions simultaneously. It is like having a massive team all working on different versions of the puzzle at the same time, instead of one person working alone.
And the framework is smart about how it manages this team. It has a two-level adaptive operator selection. In simpler terms, it dynamically chooses which moves or strategies are working best to improve solutions, and allocates more GPU resources to those promising strategies. It learns as it runs.
That is fascinating. But if it is a general framework, how do you make it work for such different problems? Packing trucks is not the same as scheduling flights.
Great question. This is where the extensibility comes in. The core framework provides the GPU engine and management, but it allows domain experts to inject their own knowledge through a user-defined operator registration interface. They can write custom, problem-specific search operations in cuDA. These plug right into the system, so a logistics expert can write the perfect truck packing move, and the framework will run it at lightning speed on the GPU.
Okay, but writing cuDA code, that sounds like a barrier. Not everyone is a GPU programming wizard.
That is the final and maybe most user-friendly layer, the usability level. They built a pure Python API. You can interact with this powerful GPU engine from Python, which is the language of choice for many data scientists and engineers. Even more, they have an LLM-based modeling assistant.
Wait, an AI helper to use an AI framework.
Precisely, you can describe your problem in natural language. For example, I need to schedule nurses for a hospital with shift constraints and skill requirements. The LLM assistant helps translate that description into the correct solver code that runs on cuGenOpt. It dramatically lowers the skill floor.
That is incredible. So what were the results? Did it actually work?
The experiments were very promising. They tested it on 5 different problem suites, using different GPU models. cuGenOpt outperformed general-purpose solvers by orders of magnitude in speed. For some problems, like the TSB with 442 cities, it found a solution within 4.73% of the optimal in just 30 seconds. It also solved 12 different problem types to optimality. The framework-level optimizations showed massive gains, reducing gaps and boosting throughput significantly.
The takeaway is this. It moves us toward a future where powerful optimization is more accessible. You do not need to be a PhD in operations research and a cuDA expert to solve tough logistical problems. This framework provides the high-performance engine and the tools to let you focus on your specific problem.
So from planning the ultimate road trip to optimizing global supply chains, This kind of technology could be a game changer, making complex optimization less of a combinatorial nightmare.
That is a perfect way to put it, Isabel.
Thank you so much, JJ Jiyoung, for that deep dive. And thank you all for watching. Remember to
Nay.
Do it.
bye everyone.